2 is the only information given here, and we expected to find the radius of this diagram. Is it really possible? Join me and see how possible this is. Welcome back to my channel. So today we have a challenging maths Olympiad question to solve. We are told that this is not drawn to scale, please. From here to here is 2, and this is the center of this circle. So for clarity's sake, I'll be naming all the points in this diagram. So let's call this point A, point B, point C. Okay, now let's call this point D and call this point E. Let's call this point F. Now let's join D to F. All right, so having done that, first of all, let's drop a straight line from this point through this place. So I'm going to drop a straight line from the center to the point of contact between this tangent and the circle. Now we have another point. Let's call this point A, B, C, D, E, F. Let's call this point G. Point G, right? This is already O. And let's call this point H. Okay. So this is point H. Now I want us to start bringing out different circle theorems that we are going to apply here. Okay? Because that is the only savior we have, the circle theorems. First of all, if a perpendicular touches a tangent at its point of contact with the circle, we are going to have 90 degrees. So it means that the angle here is 90 degrees. All right? Now, EF, because if this is the center of the circle, EF is the diameter, right? EF is the diameter. Now, remember that your diameter sustains an angle of 90 degrees at the circumference of the circle, right? So that proves that our point D is 90. Now, DBGH. Let me write this H here. Whoa. All right. DBGH is a rectangle. That means 90, 90, 90. This is also 90 degrees. Fine. Okay. Now, let us drop another perpendicular from here down. All right. Remember, a perpendicular. Emphasis on perpendicular. So, we are going to drop another perpendicular from here down. Now, let's call this point, this is HI, but instead of I, let me write J so that we don't mistake our I as 1. If this is the first time you are seeing this lovely channel, please hit the subscription button, turn on your notification bell so that you don't miss our videos. Comment, tell us how you feel about what we are doing, and I'm going to give you a feedback on my next video, right? Telling you here what I feel about your comments and what I'm going to do about it. If it's a thank you, I'm going to say that as well. So feel free to tell me what you think is good for the channel on the comments. I will reply you. All right? Thank you so much. Now, looking at this, first of all, since DBGH is a rectangle, it means that BG is equal to DH. So this is 2 as well. Now, remember that when a perpendicular touches a chord of a circle, all right, it bisects the chord into 2 parts, 2 equal parts. So this place and this place are equal, meaning that HF is also 2. All right, remember we said we are dropping a perpendicular, so this is also a perpendicular, meaning that this is also 90 degrees. Okay, let's extrapolate this to touch the circle here. We are going to see why next. So let's call this point IJK. Let's call this point K. All right. Now, if you look at this, you will notice that if this is 2, this place GJ is also 2. Now, moving forward, I forgot to write something initially, that AF is equal to FC. All right. Now, if that is true, let AF be equal to, let's call it Y, right? So if this place is Y, then AC will be equal to 2Y, since both of them are equal, right? So AC is equal to 2Y. So how are we going to indicate that? That from here to here is equal to 2Y. Okay? All right. Now, if you look at this, that means the sides, but before that, we have ADF as a triangle, and we have ABC as another triangle. Let's compare both of them. So let's compare triangle ADF and triangle ABC. Okay, so if we do that, you notice that they share angle A. Angle A is common. Angle A common. Now, this, since here is 90, that means here is 90. That means angle ADF is equal to angle ABC. So this alone is enough to qualify these two triangles to be similar, right? So it simply means that triangle ADF and triangle ABC are similar triangles. Okay, I want to be sure this is still recorded. So moving forward, remember that if they are equal, if they are similar, that the ratio of their corresponding sides are equal, right? The ratio of the corresponding sides are equal. So if you look at the side AC and AF, you can see that their ratio is 1:2, right? The ratio is 1:2. So we have 1:2 as the ratio of this side. Therefore, all the sides should have the same ratio, 1:2. So if you come to this side and we have 2 and 2 here, that is 4, right? From here, DF is equal to 4. That means that BC will be equal to 8 using this ratio, right? If DF is equal to 4, then BC will be equal to 8. And if that is true, that means JC is equal to 4, right? Because that is only when you have 4 plus 4 to give you 8 as BC. Okay, we are not there yet. We are not there yet. Now, let us look at this. There is another thing I'm just seeing. Like I said, we are applying so many circle theorems here, all right? We are applying a lot of theorems, not only circle theorems. Now, look at FC and JC. You notice that both of them are what? They are tangents, yes. CF and JC. They are what? Tangents. So using the tangent theorem, right? If you use the tangent theorem, this implies that FC should be equal to JC. Okay? So FC should be equal to, should be equal to GC, because this is the point of contact of this particular one. So we're talking of GC, not JC, sorry. Because we are focusing on their point of contact, right? This one is from F to C, and this one is from G to C. So it's GC. So if we don't know FC, but we know GC, because GC is 2 plus 4. So that means that GC is 6, therefore FC is 6 as well. So from here to here is 6. Now, we have gotten a right angle triangle that we can actually use to solve our equation, to solve our problem here. Yes, triangle FJC is a right angle triangle. So we have this FJC. So we have 4 here and we have 6 here. So we are going to find FJ using the Pythagorean theorem. So this is the hypotenuse. So 6 squared is equal to 4 squared plus FJ squared. So that means fj squared will be equal to, this will come here to give us 6 squared minus 4 squared. So fj squared is equal to 6 squared is 36, 4 squared is 16. So fj squared is 20, right? So fj will be equal to the square root of 20, and square root of 20 is square root of 4 multiplied by 5, which will give us 2 root 5, right? So it means that fj is 2 root 5. So we have fj as 2 root 5. That means hg is also 2 root 5. Okay? hg is also 2 root 5. We are coming to the end of this particular problem. Okay, now we are going to use another, I think I'm done with this one, so let me just clean it off. So we are about to use another theorem, and this theorem is what? If you look at KHG, so we have KHG and we have DF, right? KHG and DF. You can see that both of them are chords of this circle. So using the chord theorem, because they intersect at a point, using the chord theorem, we can say that GH multiplied by HK is equal to DH multiplied by HF. Okay, using the chord theorem. Now GH is 2 root 5. So we have 2 root 5 multiplied by HK. We don't know what it is, right? Is equal to DH. DH is 2 and HF is 2 as well, which will give us 4. This times this, right? So to find HK, we are going to have 4 divided by 2 root 5. And this, we remove this, we have 2. So it means that HK is equal to 2 over root 5. Now, if we rationalize, remember you must rationalize since the denominator is a sword, right? So to rationalize, we are going to multiply the numerator and the denominator by root 5. So we have 2 root 5 over 5. All right? So it means that HK, this small portion is what? 2 root 5. Now you can see that K to G is what? KG is the diameter of this circle. So KG will be equal to KH plus HG. KH or HK plus HG. Now HK is what we got as 2 root 5 divided by 5 plus HG. HG is 2 root 5. So if we add this, the LCM is 5. 5 into 5 is 1 times this is 2 root 5 plus 1 into 5 is 5 times this is 10 root 5. So this will give us 12 root 5 divided by 5, right? Because 2 root 5 and 10 root 5 are similar, so just add them together and return your root 5. So we have KG to be 12 root 5. But remember that KG is our diameter, right? KG is our diameter and we have 12 root 5. So KG is equal to 12 root 5 over 5. I think that is what I got. So the radius of the circle will be half of what? 12 root 5 over 5. And this will give us 6 root 5 over 5. Thank you so much for watching and see you in my next video. Bye.